Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to give more example related to the composite function, and then we are going to find the domain of each composite function. So let's start off with finding what is g composed of fx, and then we're going to compare the result with f compose g of x. So the function fx is given here and gx is given over here. Okay, so first step is to find g compose f of x, and this is simply g fx is going to be inside, and basically it is saying that we are going to replace x with fx here. So this guy is going to be replacing x in function g of x. Okay, so now next we will have x will be replaced with this guy. So we have 1 over x minus 3, and we have squared, and that can be simplified as 2 over x minus 3 squared. Okay. Right, next we are going to look at f compose g of x. Okay, so f compose g of x is just having gx replacing x inside function f. Okay, so gx is replacing x in function fx. So basically we are going to have this guy here. This guy is going here, and it's going to replace x. Okay, so it's going to replace x in function fx. So we're going to write down 1 over, so instead of writing down x, we're going to substitute x with 2x squared. So 2x squared minus 3, and that is already in its simplified form, so you don't have to do anything else. So just leave it as it is. Okay, so are the results the same? Obviously the results are not the same. Next we are going to continue with finding the domain of each composite function. So I feel like I need to explain more about the idea of domain, because there are still a lot of students out there that might they are still confused with how you can find the domain of the function and so on. So in a simple words, what I can say is, when you talk about the domain of a function, you are actually wanting to find what are the values of x such that the function is working just fine. So you want to make sure that if you substitute any value of any number into the function is working perfectly fine. So what are those values? Okay, now as an example, if I give you a simple function like if fx is equal to square root of x, can you think of any number such that this function here can be computed? It doesn't cause any calculation problem. So if let's say you choose x is equal to 4, clearly you can compute this function and the result is going to be equal to 2. If x is equal to, I don't know, 25.6789, whatever the value is, you can still get the square root of this number. No issue on that. But there will be an issue if let's say you choose x to be equal to -9. Obviously you cannot find the square root of a negative number, and in this circumstance the function is not working. So the function cannot calculate this value because it is a negative number. Okay, so therefore, when you talk about the domain, you are trying to come up with all the possible values of x such that the function is working just fine. So in this case, I can say that my domain is going to be the values of x, where x is going to be greater than or equal to 0. So these are the only values where the function here is working. If you consider negative values, then the function is not working anymore. So now let's go back to our original question, which is to find the domain of each composite function, and we're going to start with this first composite function that we have over here. So basically, when you have a fraction, what you need to be thinking of is you don't want to have something that divides with 0, because when you divide that with 0, then it becomes undefined, and obviously the function is not going to work anymore. So in this circumstance, we have to make sure that the denominator here is not going to be 0. So we need to find what are the values that are okay and that is not okay. All right, so if let's say I think if let's say we start off with having x minus 3 squared, and I don't want it to be 0, so I can create an inequality. So x minus 3 squared cannot be equal to 0. Okay, so based on this, we know that x minus 3 cannot be equal to 0, and therefore x cannot be equal to 3. So other values are fine, but x cannot be equal to 3. You can check, you can simply check what happens if you substitute 3 into this. Then you will get 3 minus 3, which is 0. So 0 squared is going to be 0. Then you are going to have a problem because 2 over 0 will become undefined. So now we have identified there is one particular value which make it problematic for the function, but the rest of the values should be fine. So we can write that the domain in this case is going to be equal to x, where x is all real numbers. You can take all real numbers. It can be 4, it can be 3.78, it can be negative 100.679. It doesn't matter, whatever number, as long as the number is real, but x cannot be equal to 3 or something like that. So that is the domain for this function. Okay, x is a real number, but x cannot be equal to 3. Or in other words, you can also write in this manner. So instead of writing it like this, you can also write that x is real number except x is equal to 3. So x ni nombor-nombor yang nyata kecuali x sama dengan 3. So x can be any real number except x sama dengan 3 tak boleh lah. So kecuali x sama dengan 3. Alright. So there you go. I've explained it in bahasa Melayu juga. Okay, next. Let's look at this function here. Here we have, we can follow the same idea where you can say that, well, 2x squared minus 3 cannot be equal to 0, because if it is equal to 0, then we will have a problem here. So next we have 2x squared cannot be equal to 3, x squared cannot be equal to 3 over 2, and therefore x cannot be equal to plus minus 3 over 2. You can try and substitute one of the value here inside, and you will get that the answer is going to be 0. So x cannot take this value, and therefore you can write that the domain is going to be x, where x can be any real number. So x is real number except x equal to plus minus 3 over 2. Okay, so it is saying that x boleh ambil apa-apa nombor nyata, so any real number kecuali x sama dengan plus minus sec 3/2. Makna at this number, x cannot take these values because then the function is not going to be working perfectly anymore. Alright, I think that is it. That's it. I think we are done with composite function, and thank you very much for watching.